Good afternoon, learning targets. I can apply quadratic equations to real-life situations. So, application problems are just so we can understand why we're going to use this in the real world and discover how good we are at asking questions and thinking about things logically. So when do I find the vertex of the equation? So if you haven't had this for a trimester, then this is not as simple as it looks. This is something you got to try to remember from, well, for lack of better words, 3 months ago. So vertex of the equation. First off, the vertex is going to be negative b over 2a. So you just need the b and the 2a. That's going to give you the x, or the time, or whatever it may be, but then you have to plug the x value to find y. Now, when are we going to do this? When you read a question and it talks about the maximum or minimum. Okay, so if it talks about the maximum or the minimum, if it is the greatest height or the least amount, right? So pick out those words: great, least, max, min, all right? That's when you need to find the vertex, all right? Then you have solve. When do I solve the equation? So when it asks you to solve for x or t, you can do one of the three things. You can do the graphing, right? You can x factor, or you can do the quadratic formula. Alright, so we talked about that in the last notes video, but you have those three options. So, when do you solve it? It's going to say, when does, alright, when does it hit the ground? Or hit a point. Hit a certain point. Hit a certain point. Alright? So you just start looking for keywords. Alright? It's the length of time, things like that. It's going to be awesome. So here's some examples for us. Alright, so we have the height, h, of an object, or t. It's after it's propelled upward with an initial velocity v is represented by that equation where g is the gravitational pull and h is the initial height. That is a very common physics problem. You do the problem every single time when you take calc-based physics in college. It's the easiest class in the world because if you can do it in algebra, you can do it in college. Suppose an astronaut on the moon throws a baseball upwards from 2 meters above the ground with an initial velocity of 10 meters per second. 10 meters per second, initial velocity. Suppose the gravitational pull on the moon is a constant of 1.6. Determine how many seconds it will take the baseball to return to the ground. So what this wants, return to the ground. So that means we want the height of the object to be 0. That is going to equal negative 1/2. Now up here it says negative 1/2 g. It says the gravitational pull on the moon is a constant of 1.6, so I'm going to plug 1.6 in. And that's going to be t squared plus the initial velocity of 10t plus upward from 2 meters above the ground. In other words, my equation is probably 0 equals, I would have said negative 0.8 myself, t squared plus 10, t plus 2. Alright, when I look at this problem, I'm going to do quadratic formula. Because I can realize that, hey, I don't want to factor a decimal. So what I would have done is I would have went with the negative 10, right, as my negative b. I would have went with the 10 squared minus 4 times a, which is negative 0.8 times a 2. Alright, and all that has to be divided by 2 times 0.8, negative 0.8. Alright, so then I'm going to have negative 10 plus or minus the square root. So probably somewhere I would have took a calculator. I would have got 10 squared equal to 100. Alright, I see that I need to multiply 4 times the 0.8 times the 2. Alright, that's going to give me a 6.4. Now, it would have been minus a negative, so I'm actually going to have plus 100. You're going to be adding that to the 100, so you should have got 106.4 divided by the negative 1.6. Square root of 106.4 is going to be 10.31. So negative 10 plus or minus 10.315 over negative 1.6. When I try one of those, I would have negative 10 plus 10.315. I usually hit enter, negative 1.6. So I get, if I add it, when I add it, I get this answer of negative 0.2. Then when I subtract it, I would have had negative 10 minus 10.315 in the negative 20s, divided it by negative 1.6. You're going to have 12.6. Oh, sorry. You're going to actually end up with 12.7. 12.70, but we're just going to leave them. So, seconds. Negative time. It's not an option, so that's why I just crossed it off or X'd it out. So you have time equal to 12.7 seconds. Alright, so, hey, that's a lot of me just talking you through the problem and the math, so you got to be able to pay attention. Now it says, suppose someone threw the ball from the same height and the same velocity on Earth, where the gravitational pull is the constant is 9.8. When will the baseball hit the ground? So, good news for you is the only thing that changes in the equation is that it becomes a 9.8. And 9.8 divided by negative half is actually going to be 4.9. So that's where I'm going to just write 4.9 t squared plus 10t plus 2. Right? Because those are the only things that change in that equation. So, there you go. What goes on when I hit this next one? Alright, so that's a different problem. So I'm looking at this. With the same height, same velocity on Earth, where the gravitational pull. So, let's do this. Negative 10 plus or minus square root. Alright, now look at this. It's going to be 10 squared minus 4 times a negative 4.9 times a 2. Alright, so that's going to be some value over 100 divided by 2 times negative 4.9. Alright, when I look at that, I'm going to have negative 10. Alright, I'm going to have plus or minus square root. Alright, so I know that 10 squared is 100. So when I look at this, I have negative 4 times a negative 4.9. I know that's going to be positive. Then I times it by 2, I get a 39.2. So I have this number of 39.2, and I know that I need to add the 100 to it. So I'm going to have square root of 139.2 all over negative 9.8. Square root of 139.2 is approximately 11.798. So I'm going to have somewhere, I'm going to have negative 10 plus or minus 11.798, all divided by negative 9.8. So, negative 10 plus 11.798, it's going to be about 1.798 divided by that negative 9.8 is a negative answer. So I get time to equal 1, negative 0.18. So we're going to be crossing that off. So I got to try subtracting it. So then if I take negative 10, I subtract it by the 11.798. I get a number in the negative 21. and then I divide it by negative 9.8. I know that's going to be a positive answer, and I get approximately 2.22. So those are my 2 times. I'll cross off the negative because we can't have a negative time. And there you have it, folks. We have what we need, which is a positive answer. All right, I really hope that that's all we needed to do on that problem, because I can't scroll down or anything. So we are just going to move on. All right, so that was 1, A and B. I see some light down there, which makes me nervous, but I guess we're moving on. So Jimmy John's is tracking its sales of a sub. I like this problem. The manager sees the quadratic representing this equation. See how they have y equals? So where x is the number of subs sold and y is the revenue earned, what is the maximum? Stop there. Maximum. So we talked about maximum. Maximum is an awesome problem because now we need the vertex, which you should know is a little bit easier. So if I had x equals negative b over 2a, that's what you're looking for. Okay, that b value. To me, it looks like it's a negative 250 then. Now you also have 2 times a negative 25. Look at that. The negatives cancel out. And you're going to get 5. 250 divided by 50 is 5. So now what you do is x is the number of subs sold. So we need to know that x is equal to 5. That's going to be the maximum revenue. Right? So then what I do is I go y equals negative 25 times 5 squared plus 250 times 5 plus 400. So you need to be able to plug in the 5. Alright, 5 squared is 25 times a negative 25. So 25 times 25 is going to be 625. Now lucky for you, I know that this number needs to be negative because the squared is going to be positive, then you times by negative, it's negative. So that's going to be that. Plus 250 times 5 is 1250 plus 400. Right, if you're good at math, you're going to know that this is going to be 1025. So, how many subs are sold to earn this revenue? Right, it doesn't have labels here. I know that it's 5 subs sold, 5 subs sold to make. I'm just going to write 1025. I don't know if that's thousands or if that's hundreds or what it is, but that would be the answer I would give. Should have labels. That would be a better problem. Sorry, folks. A projectile is shot vertically up in the air from ground level. Its distance y in feet after t seconds is given by y equals 96t minus 16t squared. Find the values of t when y is 96. I was about to tell you how easy this problem is. Y is 96. That means y equals 96. Is means equals. Now the problem is that y needed to be a 96, which equaled 96t minus 16t squared. So really what I'm telling you is that I have to subtract this 96. So to do that, now we're going to have 0 equals, I'm going to rewrite it as negative 16t plus 96t minus 96. We'll just do quadratic. It's good for us to practice with big numbers. So I would come over here. I'd write negative 96 plus or minus. That's going to be 96 squared minus 4 times a, which is negative 16 times a negative 96, all divided by 2 times negative 16. So, negative 96, plus or minus. So, first thing I would check is 96 squared, which is square root 9216. Now, if I remember correctly, 4 times 16 is 64 times 96. So this is going to actually be, look at this, negative, negative, negative. So this is still a subtraction. There's 3 of them. 2 of them will cancel out to be positive. You're still subtracting. You get 6,144. All divided by a negative 32. So what I would probably do is subtract the 9216. So I'm going to get 3,072. So this is actually 3072 here. So when I square root that, 3,072, I get approximately 55.426. 55.426 divided by a negative 32. Alright, so let's add it first. So usually what I do is I type negative 96 plus 55.426. Divide that by negative 32. You're going to have t equal to 1.27. Should be one answer. And then you'd also have a negative 96 minus the 55.426. You get this big negative. You subtract it by negative 32 to get the positive. And you're going to get a 4.73. So I have these 2 answers. So what that means to me is that it's going way above 96 feet. Meaning this projectile is shot up, comes back down. So what I mean by that is in my graph, this is probably the 1.27, and this one is probably the 4.73, if this was seconds going this way. Alright? Because that means that graph has 2 options where it's 96 feet. So they're both good answers. Alright? So you would have to leave both of them as possible answers. So whatever they're shooting in the air, that projectile is going way, 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 way in the air. Alright, a pan is to be formed by cutting 2 centimeters by 2 centimeter squares from each corner of a square of sheet metal, then folding the sides. If the volume of the pan is to be 441 square centimeters, what should the dimensions of the original piece of sheet metal be? So we want to know what X is. Well, good news. I know volume is always, usually what they'll say is length times width times height. So, what I would do is the whole distance across is X. So what I would have is a length of X minus 4. Because they took this X and they subtracted this 2 here, and this 2 here to get X minus 4. Well, it also says it's a square. So what happens is this to this, right? If they subtract these 2 here and these 2 here, since it's a square, you also know the width is going to be X minus 4. Now the height of it is going to be this 2. Because when these are folded up, that's going to make it have a height of 2. So now this is awesome. Because the volume is also 441. We know how to do X method. And if we don't, we'll review quick. So you have X, you have negative 4, you have X and a negative 4. So then what you do is you do this little X method thing. X times the X. Bring the negative 4 down. Bring the X down and the negative 4 across. Negative 4 times negative 4 is a positive 16. So what I would get is 440. I'd have X squared minus 4X minus another 4X plus 16 times 2. So then what I'd write is probably 2X squared minus 4 would be minus 8 times the 2. I would get minus 16X plus 32. However, to get this 441 away, I would subtract it. So So 0 would also equal this, minus 441. Well, instead of writing that, I'm going to write minus 409. Well, great news for you. Now, we can actually solve for the original value of x. And I see negative 409, and I'm thinking in my head, there is no way I'm even going to try to factor that because I'm lazy. So I would have looked at this. This 16 needs to be positive because it was a negative to start with. Right? Then we look at this. Negative 16 squared minus 4 times 2, which is a minus the 409. Now, if you put negative 16 squared in your calculator, it dishes out negative 256. Well, you need to absolutely 110% know a negative times a negative is a positive. Meaning, you need to know that this is going to be plus or minus 256 as a positive. This is the most common mistakes right here. Really, you should have parentheses about the negative 16 because it is going to be squared and become positive. Now, I see this minus and a minus. That makes this a plus here. So don't make that mistake either. These are where you make mistakes. So that's plus. Well, that's good because 409 times 2 times 4 is going to be 3,272. Okay, not really a big deal, but let's add 256 to it. It's 3528. 3528. So I'm going to have 16 plus or minus square root 3528 over 4. Square root 3528 is going to give me 16 plus or minus 59. That wasn't done very well. 59.4. No matter how I round that, I get 0.40 divided by 4. So let's try this. 16 plus 59.4 is around 75 divided by 4. I get x equal to 18.85. Now, 16 minus 59.4 divided by 4 is a negative answer, so I'm not going to use my calculator. I'm happy with the 18.85. So make sure you know, hey, if I get a negative answer for a distance, that's not possible either. So how many we got left here? Look at this. Now, word problems. We got one to do, so we can do it quick. On the banks of the Chicago River, where there's a water cannon called the water arc that sprays recirculated water across the river. The path of the water arc is given by the quadratic model, where x is the distance in river. What is the maximum height of the water sprayed from the arc? How far across the river does the water reach that height? So x is the distance across, which is good because we want the maximum height. So maximum height, remember, is actually just a vertex one. So this is just got a little bit easier. It's going to be negative 1.2 over 2 times the negative 0.006. Well, a negative and a negative is a positive, so I'm good there. So probably what I would do is put 0.006 times 2 in my calculator, and I would have got 1.2 over 0.012, and that should be 100. Alright, you got to move the decimal 2 places, or you can know that's 100. So then when I get over here, I'm going to go y equals negative 0.006 times 100 squared plus 1.2 times 100 plus 10. Now 100 squared is 10,000. And then when I times it by 0.006, I get 60. So this is going to be a negative 60. Alright, so if you can't get that, come talk to me and we'll help you out a little bit. Plus 120 plus 10. Alright, then when you get this, you're going to get 70. Good news, it's feet. So, where x is the distance across the river in feet, the height reaches 70. So how far across the river? So just make sure you go at 100 feet across the river. The water reaches 70 feet high. I don't know, something like that. So you should always answer a word problem with a sentence. Alright, that's something you should be able to do. I'll take a point off on some quizzes when you don't do that. Alright, understanding the application is more important than knowing how to do the quadratic formula now. So make sure you're communicating. Alright, we got high expectations for this trimester, so ask questions. Your ability to ask questions is a soft skill that is going to make you successful. Thank you. Have a good day.